What I'd like to do with this video is take you through the steps involved in graphing, inputting data and graphing it in your graphing calculator. Now if you have a TI-83 Plus, that's great, or if you have a TI-84, that's fine too, but pretty much all TI graphing calculators will do what I'm about to show you if they have the stat function. I think just the older versions like the TI-82s don't do it. So if you can get a hold of a TI-83 or TI-84, that'd be excellent. So what I'm going to do is take you through some of the problems that you're going to end up having to do on your homework. So this one is calculating the best fit line homework assignment. There's only two problems. We have two sets of data, and these are both linear sets of data. All we need to do is be able to graph these both in our calculator and on a sheet of graph paper, which I'll supply you. So what I want to do is take you through the steps involved in graphing this on your graphing calculator. So in the TI-83, the first thing you're going to do is set this up so that you have diagnostics on. If you want to see the correlation coefficient, you have to have diagnostics on. So in order to do that, you have to go into the catalog. So you do second and then hit the 0 button. This takes us into the catalog, and just scroll down till you get to the D's. And when you get to the D's, you'll see diagnostics on, diagnostics off. So just select diagnostics on, hit enter again, and so diagnostics should be ready to go. Now we're ready to start inputting the data into our calculator. So we're going to go into the stat menu where it says edit. We select 1 for edit, and so we have these columns, L1, L2, L3. These are our data columns. We can assign any of these columns to be X or any of them to be Y. Let's assign L1 to be X. So I'm going to start typing in this data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have all of my X data typed in there in L1. Now I'm going to go ahead and type in my distance data in L2. This is going to represent my Y variable data. 532, 640, 735, 855, 961, 1050. Alright, so L1 is my time data, and that's X. L2 is my distance data, according to this problem, and that's Y. Once I have the data typed into the calculator, I can take a quick look at what that data looks like on a graph. So to do that, I go to Zoom, and I'm going to scroll down to Zoom Stat. The reason I do it this way is because the calculator will automatically set up my window settings to fit around the data as best as possible. So if I select 9 Zoom Stat, there it is. It shows that my points are all lined up, and so I'm talking about a linear relationship here because the data forms a line. Well, I want to know a little bit more about that data. I want to know what the slope is. I want to know what the y-intercept is. And I want to be able to figure out if my data is precise. How well does the x variable correspond with the y variable? So we need to go back to the stat menu. And instead of going back and editing my data, I'm going to go to calculate. So I toggle over to calc. I'm going to scroll down to number 4, linear regression. The linear regression will statistically give you the best fit line, and it'll give you the equation for that line that fits to that data the best. Alright, so I just hit enter for linear regression, and so I have in the form of y equals ax plus b, where y and x are the two variables. A in this example is the slope. I know you're used to using m, but the calculator uses a. B is going to be the y-intercept. You're used to using b already, so it's nothing new really, it's just a different way of looking at the same equation. So the slope is 106.28, the y-intercept is negative 2.46, our r-squared value is 0.99, and our r value is 0.99. Now, r-squared and r, those are really reserved for statistic classes. We're not really going to talk too much about the r-squared value. the more important is the R value. The R value is the correlation coefficient. The R squared is the, I believe it's the coefficient of determination. But regardless, think of the R value, this correlation coefficient, as being a percentage. It's written as a decimal, but this is how precise our data is with itself. The X and the Y variable line up very well together, and on the order of 99.9%. So we can reasonably assume that this data is linear and the slope and the y-intercept are correct. So to correctly interpret what that slope means, let's go back to our problem. It says here, use your calculator to determine the equation of the best fit line. Write the equation in the correct form. So you would write that there. But what does the slope of the line indicate? It looks like we're graphing distance versus time. So that's kilometers versus hours. Whenever we compare a distance versus a time, that's a speed, or a velocity would be correct too. So the units for that would be in kilometers per hour. So 106, what was that number? 106.28 kilometers per hour is the speed. So if the posted speed limit was 102 kilometers an hour, calculate the percent error of this actual speed. And so we'd want to compare those two numbers with a percent error calculation. And I'll make an edu creations video on that so you can see how to do percent error. But you're just subtracting the two and you're dividing by the actual. And again, the correlation coefficient is just a measure of precision, how well the data lines up with itself. And so I'll let you finish that out, and I'll let you do the other problem on your own in the calculator as well. And don't forget to graph the data on a sheet of graph paper. And I have emailed that to you as a PDF. So you'll have a piece of graph paper, you can just print it and then use the instructions that I've given you to plot this data on the graph paper by hand. It's a very important step and very important piece that you need to be able to do in practice.